Right, so this in the previous video we covered the concept of methylation, right? Now this time we're going to work on esterification. So again, from the name you can figure out that probably an ester is going to be substituted in the morphine, and you're probably right. So we have a morphine here, then through the esterification will form dimorphine. So as you can see from the diagram right here, you can see we have two hydroxyl groups, right? After the process of esterification, those hydroxyl groups will convert into two ester groups. So that is why it is known as esterification. And so as a result of such a reaction, as a result of esterification, diamorphines, or also known as heroines, they have increasing side effects. So diamorphines have a much greater potency than morphine, reaching the brain cells faster and in higher concentration. So I reckon this is probably because the morphine here, these are polar, right? But the ester, the polarity is less, and they're more nonpolar. And because they're more nonpolar, the diamorphine can cross the blood-brain barrier, and in the blood-brain barrier we can see that there are lipids. So as it is more nonpolar, it can cross that nonpolar barrier of that lipid region of the blood-brain barrier and move into the brain. So diamorphines are active more by a factor of 2. And note that this also applies to its greater side effects as well as to its characteristics of tolerance and dependence. So inside the brain, diamorphine must undergo metabolic change before it can act as an opiate receptors. So the ester lengths are broken by enzymes called esterases. Hopefully I'm pronouncing that right. And so for this reason, diamorphine is described as a prodrug, meaning that its metabolic products, mostly morphine, actually bring about its effect. And so the molecular structure of diamorphine can be thought of as a way of packaging the morphine so that it can reach its target more efficiently. So this ecstasy is an enzyme that breaks down the diamorphine, breaks down the ester lengths, breaks down the ester lengths of diamorphine, releasing morphine itself, right? Releasing morphine. So it is kind of a packaging for morphine, but because it is more nonpolar, it allows that morphine to reach its target more efficiently.